So hello everybody, let us get started with our explanation of multiplicity and polynomials. Let's give an example. So our zeros, we have -2 with a multiplicity of 1 and x minus 3 with a multiplicity of 2, and this square root of x equals 4 plus the square root of 3. So what can we do then? Well, what can we do? We have to set them equal to 0. And what that means is that, so we're going to do the x equals 2, so x, so x is equal to -2, and after that we're going to set it equal to, we're going to turn it back into the reverse, you could say. We're going to inverse it, so x plus 2 is equal to 0, and that's basically one of them. So now what about x equals 3? We're going to turn it into reverse, you could say. So x is equal to 3. We're going to make it into x minus 3 is equal to 0. And then now we're going to do something special with this one. We're going to do this one. So we're going to inverse it and make it equal to 0. So what are we going to do? So x minus 4 plus the square root of 3 is equal to 0. So what next then, you might say? Well, we're going to multiply all these together to create a polynomial. So let us do that. So what we got is x plus 2, x minus 3, and it has a multiplicity of 2. So that means multiplicity of 2, you could say it's a degree, so it has a degree of 2. And then the irrational one is x minus 4 plus the square root of 3. And the special thing about it is that they're irrational conjugates. So whenever we have a plus square root of 3, we would have a x minus 4 minus the square root of 3, because it's the conjugate rule. And let us get started then. Now we're going to multiply all these together to get a really awesome thing, you could say. Hooray. So first of all, we're going to do the x minus 3 one first, because it's the simplest. So what would this one turn into? This one would turn into x minus, since it has a degree of 2, it's twice. So x minus 3 times x minus 3. And what we get is, when we multiply this out, we get x squared minus 6x plus 9. And then we multiply it by this polynomial. We multiply it by x plus 2. And then next part is to figure out these conjugates. Now, what is the rule of conjugates then, you might say? So what we get is it's equal to a squared, and I'm going to color code this, minus b. Now, what's the a squared portion, you might say? Well, this is our a squared portion. These are our a squared portions. And the b is just this. But it's just regular without the square root. So how would this look like then? Well, it would look like this. So we get x minus 4 squared minus, well, we don't have to include the square root, so no square rooting, but we just keep minus 3. And after this, once we do this, if you do all the math, you would get, we're going to multiply it by x squared minus 8x plus 13. And then all we have to do is just multiply all these together. And that will be fun, to be honest. So what we get, if you multiply all this together, we're going to first multiply these two. And what we get when we multiply these two, it will be x cubed minus 4x squared minus 3x plus 18. And keep in mind, we're still not done because we still have to bring this one down to multiply. So x squared minus 8x plus 13. And when we multiply these two together, we will finally get our final solution of this polynomial. And what we get when we multiply this polynomial, we get x to the 5th minus 12x to the 4th plus 42 x cubed minus 10 x squared minus 183 x plus 234. And we're done. That's what it is. This is the new polynomial that we formed from these multiplicity zeros. And I hope this helped. I'm going to do another example later. Just let me get this one rendered. So, yeah, goodbye.